So the next thing that I'm going to be looking at is a question that is based on graphs. I know you guys struggle a lot on graphs, but the graphs are not complicated. They are very simple, very, very straightforward. If you understand how the concept on a graph works, you will not have a problem, right? It's not about procedure. You need to understand this. It goes beyond procedure, right? Like the great Tatu Mahlatsi always says, it goes beyond procedure. What you need is what we call the concept. If you have the concept over procedure, you will always survive. In every study session that you are having, when you're sitting down and you're going through your study, right? You're trying to look at what is going on. Have the conceptual understanding, not just how to. It's always about the why. Ask that question all the time. Why am I doing this? Why? You always succeed. But if you know how, you might fall short when you get complicated questions. Time is not on our side. Let's go on with this question that you guys sent to us. So it's actually a question that combines two graphs. It's beautiful. It's absolutely beautiful. It says the following. The graph of f of x is 2 over x plus 1. Okay, let's have that down. I tried to write it down here. You can see what is happening. It's f of x. So we're told that f of x is equal to 2 over x plus 1. The f of x graph is the yellow graph, right, which happens to be a hyperbola. You need to know what is a hyperbola. If you don't know that a hyperbola has got two asymptotes, and the fact that it looks like this is its defining equation, you're going to have problems, right? And this is the graph of f, and there's another graph, the green graph, which is the graph of g of x. Beautiful stuff, right? Are drawn below. So we are told that C, the turning point of G, lies on the horizontal asymptote. Right, so this is apparently the turning point of the green graph, which happens to be on the asymptote. We were told it is on the asymptote. It's important for you to read the love letter and understand what that means for you as far as the drawing is concerned. Okay, cool. The next point says the graph of G passes through the origin. So the graph that you're looking at, the green graph, cuts the origin, right? So I'm going to have to complete my Cartesian plane. I drew my Cartesian plane in white, so it has to pass here, right? So it's going to look like this. Okay, beautiful stuff right there. So that's going to be our x-axis, such that the green graph passes through the origin, the point 0, 0. Okay, and then the last thing that we're told is there's a point B here, okay, which is directly above C. Point B has coordinates k and 14 and something here. So let's put that down here. Let's put that here. It's here, right above here. There's a point B, which I'm going to put in blue. The coordinates of B happen to be k as well as 14 over 3. So that's what B is. It's directly above point C. Okay, such that BC is parallel to the y-axis. So that's good news because it tells me that the x-coordinate at C is going to be the same as the x-coordinate at B, because that line BC is parallel to the y-axis. Oh, beautiful stuff. Okay, the first part of this question says we need to write down the domain of f. Okay, the domain. What is the domain? Okay, cool. The domain of f. The domain of f speaks to us about the x values that are covered by the graph of f. They didn't ask for the range, but for bonus, I'm also going to put the range just to assist you to understand what is going on, right? Now, think about it this way. When you're looking for a domain, you're looking for all the x values that are covered by the graph. So you look at it from left to right. You can even take your ruler. Run your ruler from left to right and check, is this graph limited in terms of moving left and right? Does it have any limitations in terms of moving left and right? Because the domain is about x values, and the x value, the x-axis moves from left to right. So what you simply do is you check your graph from left to right. Like I say, we're in South Africa, we do things from left to right, and then you double check, is there any violations there? Does the graph succeed to go all the way from left to right? If it's got a problem somewhere, then it means you need to actually take note of that, right? So let's look at the yellow graph. If I look at the yellow graph from left to right, you will see we've got a problem because it does run nicely from left to right, but you'll agree with me that it's shying away from the dotted line here. It's shying away from this blue asymptote. I'm going to put it in blue here, right? This is the x values that the graph doesn't get to. It's actually the x value that the graph doesn't get to. It does go as far left as it wants. This will go all the way to the left to as far as the graph wants. And the other piece, the other yellow piece at the top, goes as far right as it wants. So these two pieces are able to go as far left and as far right as possible, right? collectively, the other one goes to the right, the other one goes to the left. So they are succeeding to cover all x values from left to right. But both of them are shying away from some number that is between them, which happens to be the asymptote. So what I'm going to say when I'm writing my domain, I'm going to say it's all x values. The graph covers all x values except the asymptote. Right. So let's put that mathematically. So domain, my domain for the yellow graph, x is the element of real numbers, but the graph does not reach the vertical asymptote. So now I need to go to the equation and ask myself, what is this number here, right? What is that asymptote? Remember the asymptote, you check the equation is x plus 1, right? This x plus 1 that you're looking at here, right? So if you're looking for the asymptote, x plus 1 cannot be 0, so x cannot be negative 1. And then the y asymptote is going to be y is equal to 4. So this is going to be another asymptote that you actually have to keep in mind. So which means as far as x's are concerned, x cannot be negative 1 because we will have division by 0, and that is going to be the domain for a hyperbola. It's always the case. And then for the range, which was not asked, but it's just a bonus because you're watching Tenfold Live, I'm going to say y is all y values. This graph covers all y values, but it does not cover the asymptote, which in this case will be plus 4. According to what? According to the equation that was given to us. Remember, we get the asymptote from the equation using that number there and using that number 4 that you're looking at there. Those two numbers always give you the asymptote of your hyperbola. So very important to keep that in mind. Right. Okay, cool. The second question now. Let's go to the second question. The second question says we need to write the x-intercepts of f. Determine the x-intercepts of x. Now, for x-intercepts, what must happen? Every time you're looking for the x-intercepts, you want to know where the graph is passing on the x-axis. But where the graph is passing on the x-axis, y is 0. Just as easy as that. Okay, let's go back and check. Graph of f. The graph of f, the yellow graph, cuts x where? Cuts x here on the left of the blue line. That's where it cuts the graph. That's where it cuts the graph, the x-axis on the Cartesian plane. I know something already there. What do I know? Well, I know that one of the numbers there is already 0. The y value is 0. So I'm looking for the x-intercept. What I'm going to do is just taking this 0 and substituting it where I see y, because I'm looking for the x-intercept of that particular yellow graph. Right. So I'm going to say the following. This is what you guys normally say. For x-intercept, right, we're going to let y equal 0. But why? You see what I'm saying? The concept. Understand why you're saying that. It's not about the procedure. We don't always do that because we do that. We do that because where the graph cuts the x-axis, y happens to be 0. So I'm going to say, okay, my y or my f of x is going to be 0. So where you see f of x, I'm going to have 0 equals to 2 over x added with 1, right? And then we've got a plus 4 far right there. So the rest is just to solve for x. Subtract 4 on both sides or take 4 to the left, witchcraft math. You just take 4 to the left and then it changes the sign from plus to minus. You've got 2 over x plus 1, beautiful people. And then this is supposed to be divided by 1, right? And then after this, it's math, basic algebra. I'm done with graphs. Anything that I'm doing beyond this is no longer about graphs, it's your algebraic skills. Cross multiply this guy with that guy, cross multiply the other way as well. So I'm going to have negative 4 into x plus 1 equals to the product of 2 and 1. The product of 2 and 1. When you do 2 times 1, what do you end up with? Well, you end up with exactly 2. And then from here, I can just say, okay, let's just go in here. You can go in here or you can divide. It's up to you. I'll have minus 4x. I'll have minus 4 equals to 2, right? And then I'm going to take 4 to the right or add 4 on both sides. I'll have minus 4x is plus 6 when you add 4 and 2. And then when you divide both sides by negative 4, your x is going to come out as negative something beautiful, which is 3/2. Okay, is this what we expected? Yes, we expected this. It's actually negative 1.5 because it is on the left-hand side. So therefore, the x-intercept, we're answering the question. The x-intercept is going to be negative 3/2 and 0. Please answer the question by writing the coordinates the way the is asking you to write them down. Okay, the next question says we need to calculate the value of k. Find the value of k. Okay, find the value of k. Let's go and check what is this k on the drawing. If you go back, you will check that and realize that k happens to be a point on the graph of F. It's a point on the blue graph. The X value is K. The Y value is 14 over 3. This is a popular, simple question. The skill I need is a grade 8 skill, substitution. That's all I need. So what I'm going to do is I'm going to take these coordinates of B and replace them on the equation of this particular graph, which happens to be F. You always do that all the time. Without any challenges, you will be able to succeed to find the value of K. Don't stress yourself. B point on the graph of F. So take its coordinate and replace on the equation of F. You will be able to solve for what you're looking for. So let's do exactly that. So you will notice that K is actually the unknown variable that you're looking for. The Y value is 14 over 3. Okay, cool, 14 over 3. Let's come back and do that. So what do I start by doing? Okay, we are looking for K. The question says find K, right? Find K. Okay, no problem, examiner. I'm going to say F of X equals to 2 divided by X plus 1 plus 4. Why am I using the graph of F? Because B lies on F, right? And we were told that the coordinates of B are simply K and 14 over 3. So where I see Y, I'm going to put 14 over 3. So 14 over 3, right, is equal to 2 over. Where I see X, what am I putting? I'm putting K, right? Replace those coordinates there, plus 1, plus 4. Everything else stays exactly put the way it was, exactly the same. 14 over 3 is my Y value. My X value is K, so I'm going to just do my math skills and try to solve for the value of K. So I'm subtracting 4 on both sides of the equation. You'll have 14 over 3 minus 4 equals to 2 over K plus 1, right? So if you don't want to make mistakes again, you can always use your calculator to make sure that you save time and you get to the answers much quicker. Right, so I'm going to ask, what is 14 over 3, right? What is 14 over 3? Subtract something beautiful here, which happens to be 4, right? Subtract 4, we're getting 2 over 3, okay? We're getting 2 over 3, okay, 2 over 3 equals to 2 over K plus 1. And then you cross multiply here, you're going to get 2 into K plus 1. I already know that K plus 1 equals to 3. I can actually do that. You can do that. If the numerators are the same, the denominators must also be the same. So I can just equate, because this part at the top are the same, I can say 3 is equal to K plus 1 if I wanted. But for the benefit of those of you who are watching and who might be lost, this is 2 times 3, which gives me 6. If I divide both sides by 2, I'm going to get K plus 1 is indeed 3, which then leaves me with a K value of 3 minus 1. Then I'm getting that my K value comes out as exactly 2. Beautiful stuff, right? If you want to confirm this, you go back to your calculator, right? You just check that I'm looking for K. I just claim that K is 2. So if I replace X as 2, I must get that Y value that they're giving me at point B, right? If I go back and I put 2 here, I divided by, I'm claiming that my K is 2, right? Plus 1, okay? And I add that with 4, what are you ending up with? You're ending up with 14 over 3, which tells you when X is 2, your Y value is going to be 14 over 3, which confirms that indeed the coordinates of B are going to be 2 and 14 over 3. So I found the value of K. Okay, the next question. Next question says we need to write down the coordinates of C. Write down the coordinates of C. What is C? C is the turning point of which graph? Of the parabola. Right. Okay, let's go back to the sketch. Let's go back to the sketch and try to analyze this from the drawing that you're dealing with. So we want the coordinates of C. We just want to know what the coordinates of C are. Now, we were told that BC is parallel to the y-axis, right? Parallel to the y-axis. What does that mean, right? When something, a line, is parallel to the y-axis, it means they have the x values anywhere on that line are the same. The x values as you go up are always going to be the same. If x is 1 at a particular point, it's going to be 1 here and here and here. The y values are the only ones that are changing because they're going higher and higher and higher. But the x stays the same. Anywhere on that line, the x value is going to be the same. Now, since BC is parallel to the y-axis, and we already know what is the x value at B, we can steal that and use it as the x value at C, exactly without any complications. So let's come back and check that. So my K will help me because I know that K is 2, which means at C, the x value is also going to be 2, because here, anywhere here in this line, if you're going down, x will be 2 for all of them, because that line BC is parallel to the y-axis. Now, the other thing that they told us is that C lies on the asymptote, on this asymptote that happens to be the vertical asymptote, right? This asymptote here, this one here, right? It lies there. And the equation of that asymptote is y equal to, let's go to the equation of f, it must be 4. So that's y equals to 4. That means the coordinates of C must be 2 and 4 because C lies at that particular point where the graph turns on that asymptote. There's nothing wrong with the parabola cutting the asymptotes, but there's everything wrong with the hyperbola touching asymptotes. So remember, those are the asymptotes of the hyperbola, not the parabola, right? So the quadratic function can do all it likes without any limitations. So the coordinates of C are going to be 2 and 4. So let's write that down formally. I'm going to say, okay, they're looking for the coordinates of C, which is the fourth question. So C is going to be 2 and 4. And the way they're asking this question, they're not even saying calculate, they're saying write down. When we say write down, it's because this thing is in front of you, you're looking at it. That's something else I want you to carry with you when you're going to write fully blown exam papers. Always understand when we say calculate or determine, there's a lot of effort involved. But when you say write down, you're looking at the thing in front of you. It's in front of you somewhere there, either on the drawing or as part of the calculations that you have done up to that point. Beautiful stuff. Right. Okay, cool. Now, the next question is a fifth question. It's a nice question, this one. They say here we need to now find the equation of G in the form y equals to, okay, find the equation, right, of G of x. Oh, my goodness. They say in the form, right, respect them, respect the examiners. If they ask you for something, do exactly what they're asking. In the form y is a into x plus p squared plus q, right? Okay, cool. So now what's the story here? What's the story? Well, we're looking for an equation in this particular form, which means we need to know what is P, we need to know what is Q, and we also need to know what is A. That's all that we need to know, right? So this is actually not complicated. But what is P and Q? Well, it turns out that these guys are the coordinates, right? You guys know this by now, of the turning points. Now, examiners are not bad people, they're nice people. Why were they asking you for the coordinates of C in the first place? It's because they knew they're going to ask you for the equation. Now, that means since I know that the coordinates of the turning point are 2 and 4, from question 4, I'm just going to steal those and replace them for the value of P and the value of Q. Right, so I'm going to do that. So I'm going to come here and say, okay, I now know what P and Q are, which means I can upgrade my equation by writing it as follows. I'm going to say y is a into x. Now, here's the tricky thing that I want you to keep in mind. Remember, this 2 squared and plus 4. The p value always changes. If it's plus, you need to write minus. If it's minus, you need to write plus. What do I mean by that? This number that you're writing here, this minus 2 that you're writing it against the diagram. So if I go back to the drawing, the sketch, if you go back to the drawing, you will agree with me that the x-coordinate of the turning point is a positive number. Because it is positive, it means when I'm writing it as an equation, I'm going to have to write minus, not plus. You always write the opposite of what is going on. But the y-coordinate, you're going to take it as you see it, right? This one here, the x-coordinate, you're going to change sign, but the y-coordinate, you're going to take as you see it. Which means when I come back to what I'm dealing with here, that p value, I'm now writing minus 2. I'm writing x minus 2 because it is plus 2 on the drawing. And then the q value comes out exactly as 4 because it has always been 4, and we're happy with what we see right there. Beautiful stuff. Okay, cool. Now I still need to find A. I found my 2 and my 4. I still need to find A. Now, in order to find A, you need a random point. Why do you need a random point? You must find a random point that you can use to substitute for y and x so that you know all the numbers and then you can be able to find the value of A. So do we have a point that the graph is passing through? Let's go back, right? Okay, now here's something that is important that I want you guys to have in your mind. We can't use point B because point B has nothing to do with the green graph. It's a point that is lying on the yellow graph. If I was talking about the yellow graph, then I can use point B. And also, I can't use the x-intercept of the graph of f, right? I can't use that, even though I found it. But I really need to use any point that the green graph is passing through. And we were told that the green graph passes through the origin, and the coordinates of the origin are O and O, which means 0 and 0, not O and O, but 0 and 0, correct mathematical terminology. So my x is 0 and my y is 0. I'm going to replace those here. So where I see x, I'm going to replace it with 0. okay, equals to, we don't know a, all right? And where I see y, I'm going to replace it with 0. Remember, we know that this is minus 2 squared, and we know also that this is actually equal to 4. Okay, cool. So now if I subtract 4 on both sides, I'm going to get minus 4 here is a into 4, because 2 squared is going to be 4. You divide both sides by 4, you get negative 1 as your a value. Therefore, the equation is going to be y equals to negative 1, which is not necessary to write, x minus 2 squared added with 4. And that, beautiful people, is the equation. Are you happy to see a negative a value? Double check your work, double check your work. Remember the recipe for getting a distinction? This value, is it making sense? Yes. This means I'm dealing with a set phase parabola, right? I'm dealing with a set phase parabola, right? So if I'm dealing with a set phase parabola, I'm expecting the a value to be negative. Is it negative? Yes, it's coming out as negative 1. I'm happy to see exactly what I'm looking at. The p and the q values definitely come from the turning point. So this is the equation of this graph that you guys sent to us here.